Thank you so much. And we have a lot of questions here. And before we get to those questions, I got a couple things to go over, and we'll jump into them. So one thing we wanted to make sure is, if it wasn't completely obvious, was we could just quick touch on where a technology like this fits in with LEED certification, specifically on residential LEED, but there are a lot of carryovers to commercial and other green building certifications like Passive House, like Energy Star. So one that may not be so glaringly obvious is the EQ credit low emitting products, which under V4 is now out of the materials section and in the health section, which makes a lot of sense. So one area you want to focus on here is site applied adhesives and sealants have to meet the requirements of the CalForce section 7103550, and then I believe phase 2 of that. 90% of those products have to meet that to get that credit. So by having the Green Guard certification, that is one way where this technology is going to help contribute to that. And again, that is a similar requirement for enterprise green communities, National Green Building Standard, and other various green programs. Obviously, the one we hit on, and the more obvious, the much more obvious one here, is of course the energy use. So there are 3 ways to approach energy use in LEED for homes. There's the LEED energy budget, and then the HERS index rating. And then, of course, if you're doing a mid-rise building, there's the ASHRAE baseline. So without getting into too much detail, you have your Energy Star version 3 target that you have to hit, which has an ACH requirement in it. And then, of course, the further you improve those holistic energy numbers, the more points you can score in the LEED rating system. So if you're sitting down with your energy modeler, and the better you can do your ACH, the lower your air changes per hour, the lower your CFM ratings are, the better your overall energy performance is going to be, and the better your LEED points are going to be. Now, the thing is that's really important about this technology that I want to stress, besides just the obvious of energy reduction, is that we start off LEED and other green building programs, and especially the pass-fail programs like Passive House, where you're either in or you're out. It's not a point system, an Energy Star. You really need to know what your air changes are going to need to be, because that's going to, especially in certain climates like where I'm at, cold weather climates, and even hot weather climates, you really need to know where those ACHs are going to be, to know what your overall energy use is going to be, to know what your green points are going to be. So by using a technology like this, it eliminates the guesswork, and you can, right in the design stage, call out in the spec that you want to be 1 ACH, 2, 0.6, wherever you need to be. You can know, and you can be more confident about it, because a lot of times that ACH, we're just guessing, we're putting in a number, we're always just hoping, we're basing it off the last project and the last team, and especially on massive multifamily projects, you got a lot of different subs. So so this is very important, because you can really hone in and know this and call it right out from the start and eliminate that guesswork. So that's really an exciting aspect of that. And then finally, believe it or not, but air leakage is also a health impact. So LEED for multifamily and single-family attached homes has enhanced compartmentalization, which is basically just a fancy way of saying keep the smell, keep the sound, quite honestly, smell, sound, and whatever your neighbor might be smoking next door or below you or above you from coming into your unit and ruining your air quality. So it's beyond energy efficiency, and it's really getting into health. And I believe every other green building program is going to start following suit with what LEED has done here. So it's, again, really important to have that air leakage reduction. There's a baseline requirement at CFM per enclosure, so they don't measure it in ACH, but there's a baseline of 0.23 that you need to get to for the requirement in multifamily and single family attached. and then you need to be down to 0.15 CFM 50 per square foot, as you can see down there, of enclosure space to get the extra point in the multifamily or mid-rise rating system. So again, this is a big one, right? Because we start off the design phase telling teams, like, this, you know, if you do bad somewhere in energy, you can make up for it somewhere else, maybe install something more efficient in your air loss reduction. But if you do bad in compartmentalization, you're out of the game. So so a technology like this, again, can be used to know what that air target's going to be, and or, as Paul was mentioning, if a problem does occur, we recommend white boxing the first unit, testing it out, and if an issue does occur, you know, you can incorporate this technology, you know, have a line item in the budget to have extra funds for it, so you can hit those targets should a problem occur, you know, with the construction phase. So that's just another thing to consider. So anyway, yeah, we've got a lot more time for questions. I see a lot of questions rolling in. And just real quick before we get to those, for those of you watching here today live, make sure to take that survey that pops up at the end when we close out, or the same survey will be emailed to you. Take that and watch this whole session. For those of you listening to this in the future, not right now on demand, make sure to take that quiz with an 80% passing rate. Follow the instructions. If you're taking it on our website, you can head down to the YouTube logo down there at the bottom beneath the image, and then on the left there you can see step 2 is click the show more button, and on the right there step 3 is go and you will find the quiz link where you'll get the quiz and the submission access. And again, a lot of questions pouring in, but right before we get to those, I just want to thank all of our board of directors, our members, everyone who helps us do what we do, and a huge thanks to our top tier sponsors, Shrinergy for on-the-go or in your house backup solar energy battery powered systems, T-Stud structurally insulated framing systems that save energy behind the walls, Mitsubishi helping you get to net zero all electric on single family, multifamily, mid-rise, commercial, you name it, and of course Panasonic Ventilation, meeting all your ventilation needs from code all the way up to their smart ventilation system that is coming out very soon. All right, so let's take a look at some of these questions here pouring in, and Mark, if you want to help out with any of those too, I'll unmute you. So let's see, we certainly have a lot of stuff pouring in, and I'm going to see if I can bundle a couple of them together. You know, I do know one of them, some of these questions I see kind of coming together, and that's really trying to figure out, you know, really where your air barrier is then with a product like this. And also, and maybe in that conversation, we can talk a little bit about, you know, the dialogue between doing this in the framing stage versus doing it in the drywall stage, because I've heard all sorts of discussion there. So maybe we can talk about that real quick.
Sure. So when we apply aero barrier, it's really working with the builder, architect, and designer to understand where the primary air barrier is identified. Right? Aero barrier is not a primary air barrier. It's an enhancement to a primary air barrier. So we would like to apply where that primary air barrier is going to be. So we will work with the builder to try to align the primary air barrier with our application. Like I mentioned, we have to pressurize the space. So the one restriction that we have is we have to be able to pressurize. With, you know, depending on your climate zone, you know, I know here in Ohio, vented attics are pretty prevalent. We can't pressurize a vented attic, right? With the softener ridge vents in place, there's no way for us to pressurize. So we have to wait till the ceiling is in place. Now, there's two ways for us to approach this. If the primary air barrier is designated as the exterior sheathing or exterior part of the building, we can hang the drywall lid and apply at that stage and still apply it rough in, right? Just with the ceiling in place. Otherwise, we can apply at drywall once everything's roughed in and dried in, and after the first coat of drywall mud, and apply at that stage. You know, so there is some flexibility in how the technology is applied. It's really going to be project specific. Obviously, in multifamily applications or multi-dwelling applications, you really want the drywall in place because the goal or what you're achieving is compartmentalization of those units from each other. And if you're trying to do that at rough end, you aren't going to achieve that compartmentalization. Now, I will say there are some multifamily projects or certifications that require whole building testing. Aero barrier can be applied to an entire floor. So if you want to do the exterior part of a building and you aren't as concerned about the individual units, you can pressurize an entire floor and seal at the exterior sheathing of a multifamily project. That is no problem. But a lot of value comes when you compartmentalize those units from each other. For those who've done multifamily work, you know that this air sealing detail at the party wall and at the corridor can be very challenging, right? And this gives you a solution to seal it after first coat of drywall mud and to compartmentalize those units from each other and hit the blower door numbers that you're looking for on a unit by unit basis. But the nice thing about the technology, as long as we can pressurize, we can work with that primary air barrier and have a pretty good idea where the air barrier, where the air barrier is located, and seal against that surface.
And I want to follow up a little bit. I mean, one of the ideas I've heard is that after, if you do it after the drywall, there's less product you have to use, so maybe less cost. I mean, any thoughts of that? Or
yeah, that's not necessarily true. When you think about rough-in stage versus drywall, drywall has a lot of cutouts. You think about all the outlets and light switches and can lights. Those all introduce a leakage plane into that drywall. So it actually may use more sealant because there's more areas to be sealed. Whereas at rough end, there may be some holes in the sheathing, but there are typically fewer holes. And when you put the drywall up on top of that, it's going to seal all the holes on the front end of that are that could lead to the back end hole. Does that make sense?
I think so. If not, then we'll let anybody else follow up and clarify. So
sure.
So there's a lot of questions pouring in here about flexibility, durability, longevity. So let me sort of merge some of them together here and just ask, about a house, over time, moving, shifting, and then of course, just how long does this last until it degrades? So any answers on that?
Sure. So we've done lab testing and we've done field testing. Obviously, those are two different dynamics that we need to understand. And so we've done standard lab testing, which is 50-year accelerated aging and wear testing, where we make a seal and they put some pressure on that seal, and then they ramp it up to 140 degrees and let it come back down naturally, and then they take it down below freezing and let it come back up naturally. And they do that over and over again through 50 cycles while putting some tension on that joint. And through those tests, at initial seal, we are 99.9% effective, which is what you would expect from a new seal. And throughout those 50 cycles, the sealant ended up at 99.87% effective. So very little seal degradation in the lab environment through the test that you would expect this type of product to go through. Now, as far as field results, we've been working with various builders since we started to get field data. Mandalay Homes was obviously the first home builder to use our technology on every house. The first house we sealed for them was almost 2 years ago now, and we sealed it to 0.6 ACH50. We did a blower door test on that unit about 2 months ago, and it is currently sitting at 0.7 ACH50. So that's an acceptable variance in a standard blower door test for leakage. So we aren't experiencing a ton of leakage in those units, and we'll continue to test some houses with Mandalay. For those of you who are familiar with Steve Basic or Peter Yost, they work with Jake Bruton out of Aero Building, and they just applied their first 2 houses with Aero Barrier last month. And they're going to be going into those units every 6 months and testing the air leakage to again, provide another source of feedback, of field-specific feedback to how the sealant is performing. But from all the results that we have to date and at our disposal that we've gone through, the sealant performs as you would expect and continues to to perform long after, longer than the standard warranty for most products.
Thank you for sharing that. So one thing I'm wondering about too is, you get the product in there, you've set it up, you're going. So, why would you not just keep it going and seal all the way down? I mean, nearly as low as possible. How much of a financial burden is it to go from? And I know this is project specific, but just generally speaking, if your code target is 4, why not just keep on going? Like how much more of a price jump or expense is there, as you continue to go? I mean, it seems like once you've set it all up, that's a lot of the effort and work.
Sure. Yeah, and you are correct. Another 30 minutes, another 45 minutes, and you could get another ACH out of the building envelope. The one thing that we work with our installers and we do a lot of training around is, if you're going to be at 5, why not just go to 3, right? But once you start getting around 3 and below 3, you really need to have some conversations about your ventilation strategy, right? As you get tighter, I mean, it's great that we can take every house you build to 0.2 ACH50, right? But if that building is not built to manage that efficiently or effectively, you're just causing more problems, right? You're going to make the occupants sick. You're going to make that house unhealthy. So yes, there's very little cost difference going from, let's say, 7 ACH to 3 ACH or 4 ACH. Where the cost starts to change is when you start getting around 1 ACH and below. That just increases the amount of time that you're going to spend, increases the material used. So you're correct. So if you're going to go for 5, why not just go for 3? But you also have to, it's easy to say that in general terms, but you also have to think of the other dominoes that start to fall in the build process that may not be impacted by the cost of aero barrier, but may then impact the cost of the entire build.
I really appreciate you bringing up that part about the fact that you're going to need to consider your ventilation strategy, obviously from the beginning, and making sure it's correct, and kind of thinking into the solar strategy, which I assume that particular builder is able to reduce their loads on solar because they know their air changes and CFMs are going down. So on that line of thinking, what kind of conversations are your teams having, or are they trained to have that upfront discussion with the HVAC contractor? Because I know a lot of times the disconnect between air sealing, insulation, and the HVAC can oftentimes lead to an oversized system. Whereas if the HVAC are incorporating correctly the targeted CFM, they're going to be speccing right-sized systems. I mean, are those kinds of conversations playing out? Do you train folks to have those, or?
Yeah, of course. And I mean, you hit on a good point. I mean, standard, when you're looking at a software formula, the default values are typically 5 or 7 ACH50 if there's a value, right? And a lot of that is, it's no fault to the HVAC contractor. When you tell them you're going to build to 3 ACH and every other time you're building, you're at 4.5, his system is then viewed as inefficient, right? I mean, they intentionally upsize the system a little bit because they don't want to be the reason that they get a call back because the house isn't comfortable. And the real root cause of that action, or what the HVAC contractors are doing, is because the building envelope isn't consistent, right? If we can dial in a consistent air leakage target, yes, the HVAC contractor then, or the modeler, can plug that into their software. And really, it's not only about the mechanical equipment right sizing. You can right size ductwork. You can maybe reposition where those grills are in the house and what size grills you actually need. So when you start looking at manual JTS or whatever modeling you're going to do, you can not only right size the mechanical system itself, but you can also look further out and right size ductwork and everything in that system if you can get to a consistent ACH.
Great, thank you. One specific question here is, so do windows need to be protected with poly?
Yeah, and Some installers will, some installers won't. The biggest concern with windows, and like I kind of described, when we pressurize the house, the sealant particles stay suspended in the air. When we turn the blower door off at the end of that process, we do whatever we can to move sealant particles out of the space. But at the end of the process, anything left in the air is going to fall to the ground, right? Gravity is going to take effect and they're going to go to the ground or whatever horizontal surface is there. So when we protect windows, it's a lot about protecting the horizontal. We will take into consideration things like weep holes or maybe a junction in the double hung window. But as long as the windows are installed properly and operating as we would expect, there's not a whole lot of prep there outside of the finished horizontals and things like weep holes.
Great, thanks. So let's talk a little bit about isolation of units or even rooms from each other, and then obviously a gut rehab and is one thing when you don't have people living there, but it seems like an entirely different challenge if you're doing an existing home that's occupied. So can you speak a little bit more to that, to some of those different challenges or opportunities?
Sure, and you made a very good distinction. Occupied is very different than finished. Finished houses that are unoccupied, we can do all day, and it's relatively straightforward, right? There's obviously a lot more finished horizontal surfaces in that space that need to be protected, and that's really where the cost driver is, or the cost difference is between construction stage versus finished stage, because we have to protect all the carpets and floors and counters and vanities and things like that. But the process itself doesn't really change as it relates to sealing that structure, whether it's finished or unfinished. We as a company, we don't do a lot. We won't go out and do occupied houses. And I'll preface that with the installers in the marketplace. We have installers in the marketplace across the country that are willing to do that. It just depends on who that installer is, and you just have to understand there's a lot more risk involved when you start talking about people's material belongings in a space. Instead of just having to protect the hardwood floor, you're protecting Mrs. Jones' sweaters, shoes, and couch too. So it can be done, and we are having installers do that across the country. You essentially treat it like you're going to paint the house, and you move everything to the center of the room, or whatever you can move to the center of the room, and you tarp it off and you cover it to the best of your ability. So that work can be done, and the work the grant that we got that we're going to be doing with the DOE starting this spring is specifically focused on finished houses, not occupied houses. So there's a lot of housing stock in the market today that is very inefficient and just not in a good state. So how can we impact that in a meaningful way? It's not necessarily looking at how can we impact the house that you're living in right now.
Well, I'm glad you brought up painting. So if you needed to completely repaint a room or the house or something, it sounds like this could be a perfect 2-for-1 time to do that, right?
It could be, yeah. Tenant turnover. We have a bunch of installers in the marketplace that when they bought a new house, before they moved in, they just air sealed it, and that's a really straightforward, easy way to do it. But yeah, if you're going to do it with things in place, yeah. I mean, if you're going to paint or do something like that, it could be a good time to take advantage of that.
What's your, for a home that's existing, obviously, what's your do you have any average estimated production or percent reductions, or do you see that it's tougher to get to those lower ACH numbers, or any just genuine thoughts on that?
And you're talking about existing homes?
I'm talking about not gut rehab stage existing homes, yeah.
Yeah, so it really depends on the house. We have one of our guys in Arizona bought a house and it started at 6 ACH and he took it to 0.6 ACH. So again, the process itself doesn't necessarily change there. We can take it as tight as someone really wants us to. You just run the system longer. But again, reiterating, especially with that example, he then brought an ERV into that space and reconfigured his mechanical ventilation, because obviously that house that he bought was not designed to support a 0.6 ACH air leakage. But from that standpoint, it doesn't change our process, and we haven't seen a change in our ability to hit leakage targets that the customer is looking for.
And for the project you're working on with DOE, do you have already the homes identified, or can people reach out and put theirs up for you?
Well, and so we have a couple markets. We're trying to get a couple different climate zones, and being that it's working with the DOE, they have specific research requirements as far as who's in the market for that. So we're going to be doing some work in Minnesota. We're going to be doing some work in California, and we're actually talking to NYSERDA right now to do something in the Boston, New York area. So those are the three markets that we've kind of identified, or that have been identified for us. And then we'll kind of go from there.
Changing gears a little bit here to health, great to see, all those aspects of the Green Guard Gold certification. I'm wondering if you have any studies on real world post-occupancy. So whether it be an existing home or whether it be, the same two identical homes being built next to each other, one with aero barrier, one without it, just any kind of, VOC studies or anything else in regards to air quality, or any plans to do that.
And when you say air quality as it relates to the sealant that we injected, or just improved air quality in general?
Yeah, so so example is we're really accustomed to doing energy inspections and energy ratings, right? And we know what an energy mile is going to be. Well, the future is now we're kind of at the end of construction doing like an air quality monitoring test where we're looking at all sorts of levels of VOC. So the question is more just whether it improved or not. That's great, but just whether what did change, whether again from an existing home to one that had it that didn't, or again somebody building new homes where they'd use the same exact construction process, but maybe one had aero barrier and one didn't.
Yeah, sure. So we full transparency, we have very little data to date. We're doing testing and have done testing. That's a really hard thing to measure. The sealant itself is almost no VOC. It's classified as ultra low VOC, and it's a water-based compound. So when you think of a 2,000 square foot house, right, we're using a 5-gallon bucket of material typically to do the entire house. What a lot of people don't think about is only 20% of that bucket is actually solid material. The rest is water, which we use to aerosolize and transport the sealant. So in a 2,000 square foot house, you're talking about 20% of a 5-gallon bucket. So 1 gallon of material is actually solid content. So when we go and do our test, right, we've measured the sealant injection and what ends up in the wall system. And when we talk about measuring it in a wall system, we're talking about grams of material, right? It's not an absorbent amount of material. And because we self-identify the leaks with the air movement and seal the leaks at the same time, there's not this excess material all over the house, right? It is only being used where it is needed. So we can be really effective in our material usage and not need to use crazy amounts of material and still achieve the results that we're looking for. So the material being introduced is grams of material in a wall system. So overall, you can talk about FUBOTs or VOC testings or whatever when the house is done. But in the grand scheme of things, the amount of material being injected and used in the process is very, very small.
Great, thanks. Go ahead, Mark.
I was just going to point out, too, one thing to think about that I've talked with some people about when we kind of think about that topic is comparing that idea to how much caulk there would be in a house that was trying to get really tight by just doing some of the more traditional things where people are, caulking every framing member every time there's a stud touching any sheathing. You end up with, probably 100 tubes of caulk that you would go through, and it's just that much more product, that much more waste when you're not able to have the product self-identify where it needs to be, and you just need to put it everywhere, which is what you need to do if you're really trying to get to very, very tight levels. So again, just a comparison point to really the conservation and kind of green effect of the technology.
Mark, that's a fantastic segue into the next question. I really appreciate that, because the next question, again, we're measuring energy performance. We're starting to measure water performance. As I mentioned, we're measuring air quality performance, and I think the next level is embodied energy. These questions are going to be asked about our new energy buildings. How much embodied energy, embodied carbon is in there? So the specific question, kind of was like, what is the embodied carbon of this product versus other air sealing alternatives such as caulk, as you mentioned, or spray foam? Any thought into that, or are you going to be tracking that and reporting that as well?
Yeah, so if you're familiar with Tremco, Tremco is our sealant partner. So we didn't develop the sealant ourselves. We've worked with Tremco, which is a commercially available, typically exterior applied air barrier products. So Tremco is the manufacturer of our sealant, and we have actually reached out to them. It's not the first time we've got this question. It's starting to come up more and more often, especially when you think of things like WELL Standard Living Building Challenge. People are starting to pay more attention to this kind of stuff. So I don't have a good answer for you today, but we have asked Tremco to help provide information around that. So that will be something that we will be tracking and publishing. And just kind of in that vein, I know a lot of people on the phone are probably familiar with Living Building Challenge or the Red List. And just to, I guess, fill everyone in on our progress with that. So we've engaged with Living Building Challenge, and we've been certified that our product is not on the Red List. The challenge we run into with Living Building Challenge is the entire ingredient list has to be published on the outside of the container in their typical certification process. And being that it's a proprietary sealant to us and Tremco, Tremco in particular is not all that interested in publishing the entire recipe for the sealant. So we're working with Living Building Challenge to understand if there's another path to market with them that we can still leverage their certification because we qualify without uncovering the proprietary information that's involved in the sealant itself. So, we do take great pride in the sealant that we've developed, and we think it is a really great product, and we're trying to put all these pieces together to show that it is what it is. But there are some things that we are working through with that group to just show that we are on the Red List and be able to market that attribute.
Yeah, thank you for sharing that. I really appreciate it. Another question is the cleanup process and removal. It sounds like that's going to be part of the installer's job, but is there any kind of harsh chemicals or anything that's needed to do that?
Nope. And we typically include an industrial grade citrus-based cleaner in our system, with our systems. If there's any cleanup like that, if you get to it right away, right after the seal is complete, a little elbow grease and water will take it off. If it sits a little bit, then you may need some citrus-based cleaner to help break that down a little bit.
Yeah, and I can attest to that too. And as being an installer, in the situations where there is a film or the product gets somewhere where I didn't intend it to get, which hasn't been all that often. It hasn't really been a major problem for us. But to Paul's point, that's been exactly my experience. Is it comes off with, I don't even have to use any sort of cleaner. It just comes off. If we get to it right away after the seal, which is what we do, we try to leave the house in as good of shape, if not cleaner, than when we got there. And with just a wet rag, some water, and some elbow grease, everything has come off. And in instances where we do have to come back a couple days later, if there's something more sealant found somewhere, again, that product, that cleaner, citrus-based cleaner, removes any mess.
Thanks, Mark. So do your installers, are they required to go through, because they're doing blower door testing and there are specific things you have to look for when you're doing a blower door test, are they required to go through any BPI training or certification or ResNet training or certification or or contract with somebody who has that credential?
Yeah, so we look for them to partner with them. So one distinction to make is the blower door test that we do is more of an enclosure test, right? We're doing positive pressure, not negative pressure, and everything's taped off, right? So when you think about the test that we're doing, it's more of an enclosure test and less of an as-built test. So when you think of ResNet and the different rating or different testing that you can do, that's more of an as-built test where the dampers are going to be in place and it's going to be, nothing's going to be really taped off, right? So there's distinct difference between the two tests, and we don't claim to be an as-built test. We build some leeway and flexibility, or some leeway into our seal, because we know we're taping a lot of stuff off, and we know that there's going to be a delta between our final number and the final blower door test, because when we take off our prep work, we're going to reintroduce some of that leakage. And we all know that dampers don't always seat themselves properly, or there's going to be leakage somewhere in an area that aero barrier is not intended to seal, but that we prepped and is then going to reintroduce some leakage. So we build that into our process. And no, we certify our partners to run the process and run the system. But because we are not necessarily certifying that house for code purposes or what have you, they aren't required to go through BPI or ResNet standard. We do have continuing education that we do for all of our partners. You know, we just had Peter Yost do a day of building science training with all of our partners. So we do that kind of training, but because it's not a third-party rated blower door test, there's no ResNet requirements or things like that. But I think Mark can speak to it. A lot of our partners and installers do go get that certification or have that certification, but it's not a requirement.
Yeah, and also the other thing to remember too is even if the installer is certified to be providing the blower door, in that instance, unless we're in a situation where we're coming in at the very, very end of the process, all the trim's up, all the cabinets are in, which is rare. The more common situation is at rough-in or at drywall. And at that point, even if we are certified, that wouldn't count as your certified blower door, just from the sense of the house hasn't been finished, it's not in lived-in condition. I can also tell you though, even though the system, the aero barrier system, and what we've been trained on is to do a pre-seal blower door test with everything taped off, and then do a post-seal blower door test with everything taped off. I can tell you that when we do jobs, and I'm pretty sure that just about all the installers, I've talked to quite a few of them, we all will do a test at the end after we untape and unprep everything, just from the standpoint of having more data ourselves to be looking at, and we know we're curious, we know the builders or architects are going to be curious. So I'll usually start with a blower door test before I prep, and then I'll prep, tape windows off, do a test, we seal, we do the post-seal test with everything taped off, and then we actually untape everything, unprep everything, and do another test at the very end, just so we can see ourselves how things change. And we do see, you know, even just with the quality of windows, if they're not, you know, the greatest windows or the highest quality windows, we could see quite a bit of leakage just from untaping the junction part of the windows.
Great, thank you for adding that in, Mark. Well, we are at our time. I don't see any more questions. So just real quick before we head out, if you two could reiterate where people can contact you and learn more. If you're in the Michigan area and you want to get moving forward, Mark, where can people reach out to you?
Yeah, you can send me an email at, my email is there on the screen, mark@616homes.com. Or you can check out our website, which is aerobarrierwestmichigan.com. We've got a phone number and some contact forms there. There was another question. I tried to answer some questions as we went here. One of them was about getting quotes, and we can do those very quickly. So just reach out through the website or directly to me, and we can talk about your project.
Great. And Paul, where can people reach out to either contact you, learn more about AeroBarrier, or learn more about people who can help them anywhere else in the U.S. or planet?
Sure. So yeah, we currently have about 76 installers in North America. So if you're looking for something outside of West Michigan where Mark is, you can visit aerobarrier.net. That is our main website as a locator for our installers across the country. You can find your local installer there. If anybody would like to reach out to me directly, you can reach out to me on the email address that's on screen, paul.springer@aeroseal.com, and I can help you any way that it's needed.
All right. Well, thank you, everyone. Have a great rest of your week and a great holiday. Take care, everyone. Goodbye.